if A is equal to a set A comma B, another set B is equal to C, D and E. So A contains 2 elements, B contains 3 elements, then the Cartesian product of these two sets is denoted as A cross B. A is nothing but set of all first elements of this Cartesian product. So first element 2, A already 2 is taken, again 4, then 7 and 9. The set of all first elements of the relation is called the domain, and the set of all second elements of the relation is called the range. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss very important concept that is called relations. So you have relations and functions. So let us discuss relations and the problems based on relations and different types of relations. Now let us come, before going to the exact definition of a relation, let us know regarding an ordered pair. What is an ordered pair? Pair means 2. So ordered pair is nothing but A comma B, denoted as A comma B, in which first member is an element of set A and second member is an element of set B. So ordered pair is denoted as A comma B, where A is the first member. This belongs to the set A and the second member belongs to the set B. Now let me define the ordered pair. How to define the ordered pair? Let if A, any element A belongs to a set A, capital A, and another element B, small b, belongs to the set capital B, then the ordered pair of A and B, the ordered pair of the elements A and B is denoted as A comma B, A comma B. That means A, the first member, is element of the set A and the second member B is an element of the set B. So denoted as A comma B. Now here A is the first element and B is the second element. Now let us consider, for example, 1 comma 2 is an ordered pair in which first member is element of set A and 2 is an element of the set B. So suppose if 1 belongs to the set A and 2 belongs to the set B. Similarly, if A comma B or C comma D. So these are all called as the ordered pairs. Now equality of ordered pairs. When did you say two ordered pairs or equality of ordered pairs? So two ordered pairs A comma B and C comma D are said to be equal if and only if the corresponding elements, first element is equal to first and the second element is equal to second. If A is equal to C and B is equal to D. So two ordered pairs A comma B is equal if and only if A is equal to C and B is equal to D. If A is equal to C and B is equal to D, then these two ordered pairs are said to be equal. Suppose, say for example, if x comma y is equal to 2 comma 3, these two ordered pairs are equal if and only if x is equal to 2 and y is equal to 3. If x is equal to 2 and y is equal to 3, then these two ordered pairs are said to be equal, right? Now that is regarding an ordered pair. Now by knowing ordered pair, let us know regarding the relations. Now before going to the exact definition of a relation, let us know regarding the Cartesian product. The Cartesian product of two sets A and B is denoted as A cross B. The Cartesian product of two sets A and B is denoted as A cross B is called the Cartesian product. So the Cartesian product of two sets A and B is denoted by A cross B is the set of all ordered pairs A comma B for all A belongs to A and B belongs to B, in which first member is an element of set A and second member is an element of set B. Let us consider the Cartesian product of A cross B is denoted as A cross B is equal to A comma B for all A belongs to A and B belongs to B. Let us take a small example. Let if A is equal to a set A comma B, another set B is equal to C, D and E. So A contains 2 elements, B contains 3 elements, then the Cartesian product of these two sets is denoted as A cross B. A cross B is equal to A comma C, A comma D and A comma E. Similarly, take the second element B comma C, B comma D and B comma E. This is called the Cartesian product. Similarly, if you want to write the Cartesian product of B cross A, B cross A is equal to, what is B contain? C, C comma A, then C comma B. Similarly, D comma A, then D comma B, and the last element E comma A, and E comma B. This is the Cartesian product B cross A. Let me take one more example. Let us take one small example. If A is equal to 1, 2 and B is equal to 3, 4, then the Cartesian product of these two sets A cross B is given by A to B. A into B is nothing but, take first element 1 comma 3 and same 1 comma 4. So 1 comma 3, 1 comma 4. Similarly, take the second element 2 comma 3 and 2 comma 4. This is the Cartesian product A cross B. Now B into A, B cross A can be written as the Cartesian product of B and A. B cross A is equal to, let us take the elements of set B as first 3 comma 1, then 3 comma 2, 3 comma 2. Similarly 4 comma 1 and 4 comma 2. So these are the Cartesian product. This is how we are going to write the Cartesian product. These are all the set of all ordered pairs, a set of all ordered pairs A comma B. Right. Now, by knowing this, let us take few problems based on this Cartesian product. Now, if these are very important type problems for 5 marks. If A is equal to 3, 5, 7, B is equal to 5, 7, 9, C is equal to 7, 9, 11, find A intersection B intersection C cross C. Now, first find out A intersection B. A intersection B. You know, as intersection is nothing but the common elements. What are the common elements in A and B? So A contains 3, 5, 7, B contains 5, 7. The common 3 is here, it is not 5 and 7. 5 comma 7 is the common in A and B. So now A intersection B intersection C. So the common element in A intersection B and C. What are the common elements in these two? So here 7 is there. We can take 7 and 5 is not there. 9 and 11 is also not there. A intersection B intersection is 7. So the common element is 7 in all these three sets. Right. 5 is here but 5 is not there. We have 3. 3 is not in A, B and C. Now what is to find A intersection B intersection C? Now A intersection B intersection C cross C. Now that is nothing but A intersection. So 7 cross, what is C? C contains 7, 9, 11. So the Cartesian product of these two is 7 comma 7, then 7 comma 9 and then 7 comma 11. That's it. This is the Cartesian. If you do this much, you will get 5 marks. So just find out the common element in all these three sets. The common element is 7. So A intersection B is 5, 7. A intersection B intersection is 7. The common in these two is 7. Now A intersection B intersection C cross C. The Cartesian product of C and A intersection B intersection C is this: 7 comma 7, 7 comma 9 and 7 comma 11. This is how we are going to solve the problem. Now let us take one more example. If A is equal to 3, 5, 7, B is equal to 5, 7, 9, C is equal to 7, 9, 11, find A intersection B cross B intersection C. Now let us find out first A intersection B. A intersection B. The intersection is nothing but the common element. Common in A and B is 5 comma 7. Similarly, B intersection C. The common in B and C. B and C contains 7 and 9. 7 comma 9. Right. So, see here, first A intersection B. The common element in A and B is 5 and 7. Similarly, B intersection C. B intersection C means the common element in B and C is 7 comma 9. Now, what is to write? Now, therefore, A intersection B cross B intersection C is nothing but the cross product of 5 comma 7 into 7 comma 9. What is this equal to? This is equal to the set of all ordered pairs 5 comma 7, 5 comma 9, then 7 comma 7 and 7 comma 9. This is how we are going to find A intersection B cross B intersection C, ordered pair. Now let us take similar type problem. Say if you want to find, suppose if you want to find A cross B, the Cartesian product of these two. So the Cartesian product of these two can be written as 3, 5, 3, 5, 3, 7, then 3, 9. Similarly, let us take 5, 5, 5, 5, 7, 5, 9, 5, 5, then 5, 7 and 5, 9. Next take 7, 7, 5, then 7, 7 and 7, 9. This is how we are going to find A cross B. On the other hand, suppose if you want to find B cross C, similarly, if you want to find the Cartesian product of B and C, B cross C can be written as 5, 7, 5, 9, then 5, 11. Similarly, take second element 7, 7, 7, 9, 7, 11. So 7, 7, 7, 9 and 7, 11. And the last element is 9, 9, 7, 9, 9 and 9, 11. So this is how we are going to write the Cartesian product of any given set. Right. Now let us take next set of problems. If A cross B, the Cartesian product is given. If A cross B is equal to minus 1, A, minus 1, B, minus 2, A, minus 2, B, 3, A, 3, B. Find A and B. Here the Cartesian product is given. We want to find the set A and set B. Now this is given. So what is A? As you know, first A is nothing but set of all first members, first element of the Cartesian product. So first member is here minus 1. Already we have taken minus 2 and 3. So A is equal to minus 1, minus 2 and 3. The set B is equal to the set of all second elements, second members of the Cartesian product. What are the second members? A, B is repeated. So that's all. So A is equal to here set A is equal to minus 1, minus 2 and minus 3. Whereas the set B is equal to A, B. That's it. Suppose, let us take one more example. If A cross B is equal to 2, 3, 2, 4, 2, 5, then 4, 6, 7, 8, 9, 10. Then what is this A? The set of all elements. Now to find A is nothing but set of all first elements of this Cartesian product. So first element 2, already 2 is taken, again 4, then 7 and 9. So A contains 2, 4, 7, 9. Whereas B is equal to, what is B? Second elements 3, 4 and 5, 6, 8 and 10. That's all. So in this example, it may satisfy the relation, whatever the condition it will satisfy. But what is required to find is the set of all first elements of the set and the second elements of this set. Right. Now let us take one more example. This is very, very important type problem. So if 2x plus 4, 3x plus y is equal to 8, 0, find x and y. Now by equality of ordered pairs, 2x plus 4 is equal to 8 and 3x plus y is equal to 0. First element is equal to first, second element is equal to second. 2x plus 4 is equal to 8 means 2x is equal to 8 minus 4. So 2x is equal to 8 minus 4 is 4. Therefore x is equal to 4 by 2, x is equal to 2. And from this y is equal to minus 3x, substitute the value of x. What is x? X is equal to 2. So y is equal to minus 6. So therefore y is equal to minus 6. So here x is equal to 2 and y is equal to minus 6. That's it. If you want, you can verify. Let us take the second equation, verification. 3x plus y is equal to 0. 3 into what is x? 2 plus y is minus 6. 6 minus 6 is equal to 0. The equation is correct. Right. So therefore x is equal to 2 and y is equal to minus 6. That's it. Now let us take similar type problem. If x plus y, x minus y is equal to 5, 1, find x and y. Same, by equality. Here x plus y is equal to 5. Let us represent this as equation number 1 and x minus y is equal to 1, equation number 2. So first element is equal to first, second element is equal to second. X plus y is equal to 5, x minus y is equal to 1. Now solving 1 and 2. Solving 1 and 2. If you solve x plus y is equal to 5, x minus y is equal to 1, add this. Minus y plus y gets cancelled, 2x is equal to 6, x is equal to 6 by 2 is 3, x is equal to 3. Substitute this value in any one of these equations. Let us take from 1 itself. From 1, x plus y is equal to 5, y is equal to 5 minus x, that is 5 minus, what is x? 3, that's equal to 2. So y is equal to 2. So therefore, x is equal to 3 and y is equal to 2. So if you want to verify, just take what is x plus y. X plus y is 5, 3 plus 2 is 5, that's it. This is how we are going to solve this problem. Now, let us take one more example. Suppose if 2x plus y comma x plus 2y is equal to 1 comma 2. Now, how to find out the value of x and y? Equate it. 2x plus y is equal to 1 and x plus 2y is equal to 2. Now, here these are two linear equations. How to solve these linear equations? Now, just multiply this with 1 and this with 2. So, you will get 2x plus y is equal to 1. This is 2x plus 4y is equal to 4. Now, subtract. If you subtract, this becomes minus and minus. Plus 2x minus 2x gets cancelled. Minus 3y is equal to minus 3. Therefore, y is equal to plus 1. Minus 3 by minus 3 is plus 1. Y is equal to plus 1. So, from any one of the equations, let us take from this one. 2x plus y is equal to 1. From 1, 2x plus y is equal to 1. What is required to find is x? 2x is equal to 1 minus y. This is 1. Y is equal to 1. 1 minus 1 is 0. So, x is equal to 0 by 2 is equal to 0. X is equal to 0. Therefore, x comma y, x is 0, y is equal to plus 1. So, if you want to verify, you can verify. Take any one of these equations, take this itself. From this equation, 2x plus y is equal to 1. From this, 2 into what is x? X is equal to 0 plus y is 1 is equal to 1. So, 1 is equal to 1. That's it. This is how we are going to solve. Now, let us come to the exact definition of a relation now. Now, what is a relation? This is very important definition. So, a relation is the subset of the Cartesian product A to B. That is, if A and B are any two sets, let A and B are any two non-empty sets, then a relation R from A to B is a subset of A cross B. The subset of the Cartesian product A and B is called the relation. If A and B are any two non-empty sets, then the relation R on the set A and B is the subset of the Cartesian product A cross B. R is the subset. R is a subset of A cross B. The subset of the Cartesian product A and B is called the relation. So, R is a relation from A to B if R is the subset of A cross B. A relation R from A to A is a subset of A cross A itself. A set A has, suppose if a set A has m elements and the set B has n elements, then the number of elements in A cross B. So, A cross B will have 2 to the power of mn subsets, right? Then, if there exists 2 to the power of mn relations from A to B, and also the relations is also from A to B is 2 to the power of mn, then there are 2 mn relations from B to A also. So, if R is a relation from A to B, x comma y belongs to R, then this is denoted as x is related to y. Okay. So, if A is related to B, A is related to B is nothing but A comma B belongs to R. If A comma B belongs to R means A is related to B. So, the subset of A cross B is called the relation. Now, let us take an example. If A is equal to 1 comma 2, another set B is equal to 2 comma 3. R is the relation. Let us define a relation. R is equal to x comma y such that x is less than y. X is less than y. X comma y such that x is less than y, where x belongs to A and y belongs to B. So, what is the relation? R is equal to, so first write down the Cartesian product from A to B. A cross B. What is A cross B? 1 comma 2, then 1 comma 3. Similarly, 2 comma 2 and 2 comma 3. Now, what is the relation? The relation is defined as x is less than y. X is less than y. So, x is less than means 1 is less than 2. We can take 1 comma 2. Again, 1 is less than 3. 1 comma 3. 2 comma 2 we cannot take because 2 is equal to 2, x is equal to x, and 2 comma 3. 2 comma 3. So, this is the relation. That means this R is the subset of A cross B. The subset of A cross B is called the relation. Now you got an idea, right? See here. So, a relation R from A to B is the subset of the Cartesian product A cross B. See here, there are two sets A and B. What is A contains 1 comma 2, B contains 2 comma 3. The relation is defined by R is equal to x comma y such that x is less than y. First element is less than the second element. Now write down all the Cartesian product, cross product of A and B. A cross B is equal to 1 comma 2, 1 comma 3, 2 comma 2 and 2 comma 3. In this, find out the relation such that first element is less than the second element. What is the first element less than second element is 1 comma 2. 1 is less than 2. 1 comma 3. 1 is less than 3. 2 comma 2 we cannot take because 2 is equal to 2. 2 is less than 3. So, first element is less than the second element. This is called the relation, and this R is the subset of A cross B. Right, that's it. This is called a relation. So, a relation is the subset of the Cartesian product A and B. Hope you got an idea. Now, let us take an example. Let us know regarding the domain and range of a relation. Let A and B are any two non-empty set. R is a function, R is a relation from A to B. That is, R is a subset of A cross B. Then the domain of R is defined as the set of all first elements of the ordered pairs A comma B belongs to R. That means, the set of all first elements of the relation is called the domain. The set of all first elements of the relation. The set of all first elements of the relation is called the domain. So, domain is denoted as domain of R is equal to A belongs to A such that A comma B belongs to R, in which first element is called the domain. The range is defined as the set of all second elements of the ordered pairs in R. That is, A comma B belongs to R, denoted as range of relation R is equal to B belongs to R such that A comma B belongs to R. So, in general, the set of all first elements of the relation is called the domain, and the set of all second elements of the relation is called the range, and the set B itself is called the codomain. Now, let us take an example. Let me explain with a small example. Now, let us consider if A is equal to 1, 2, 3. Another set B is equal to 2, 3, 4. Then define a relation R is equal to x comma y such that x divides y. First element will divide the second element. Now, write down the Cartesian product first, A comma B. The cross product of A and B. A and B is 1 comma 2, 1 comma 3, 1 comma 4. Similarly, 2 comma 2, 2 comma 3, 2 comma 4. Then 3 comma 2, 3 comma 2, 3 comma 3 and 3 comma 4. This is the cross product. This is the cross product A cross B, the Cartesian product. Now, in this the relation. What is the relation defined? R is equal to. The relation is defined as x divides y. First element will divide the second element. So, 1 divides 2, 1 divides 2, 1 divides 3, 1 divides 4, 1 comma 2, 1 comma 3, 1 comma 4. 2 will divides 2. 2 does not divides 3. And 2 divides 4. We can take 2 divides 4. 3 does not divides 2. 3 divides 3. And 3 does not divides 4. This is the relation. Okay. See here. Condition. First element will divide the second elements. X divides y. 1 comma 2, 1 comma 3, 1 comma 4. 2 divides 2. 2 divides 4. 3 divides 3. In this, write down the domain. Let us write down the domain and range. So, therefore, the domain of R is equal to set of all first elements of the relation. The set of all first elements of the relation is called the domain, and the set of all second elements of the relation R is called as the range. So, what are the set of first elements? 1, then 2 and 3. This is called the domain of R. The domain of R is the set of all first elements of the relation. What is the range? Range is the set of all second elements. Range of R is equal to set of all second elements of the relation. Second elements 2, 3, 4. 2, 3 and 4. 2, 3, 4. This is called the range. Right. And the set B itself is called as the codomain. This is called the codomain. Codomain. Right. So, set of all first elements is the domain 1, 2, 3. Set of all second elements of the relation R is the range. This is how we are going to write the domain and the range and codomain for the relation. That's it. So, hope you got an idea regarding a ordered pair and the relations. That's all regarding this session. In the next session, I am going to discuss regarding different types of relation. Very, very important concept. Don't miss the class. Attend the class. Thank you. Thank you very much.